Welcome to Spring LIB.
This question deals with the concept of electrolytes in solution chemistry. And when you think of an electrolyte, you want to think of ions. So electrolytes produce ions in solution when they dissolve in water. And we're asked to look at a series of examples here and determine whether they are not just electrolytes, but whether they are strong or weak electrolytes, or if they don't dissociate into ions at all, they would be non-electrolytes. The first example is a weak acid, sulfurous acid. And when sulfurous acid is essentially in the presence of water, it will dissociate into some hydrogen ions and a conjugate base, um, the bisulfite ion. And not a lot of dissociation into these ions takes place. And remember, ions are necessary to classify something as an electrolyte. There are some ions present in terms of the weak acid, sulfurous acid, but a lot of it stays in a molecular form. And this is what we call a weak electrolyte. Weak electrolytes partially dissociate um, in solution to produce some ions, but um, weak electrolytes also stay in a molecular form, and so there's a presence of some electrolytes or ions in solution, but um, certainly not completely dissociate into ions. So weak acids and bases tend to be good examples of weak electrolytes because they partially dissociate into ions, but not completely the way a strong electrolyte would. This is ethanol. Ethanol doesn't dissociate into ions at all when it's dissolved in water, so it would be a non-electrolyte. Ammonia is a weak base, so it will furnish some ions, like the example of the weak acid above, but a lot of it will also stay in its molecular form and will only furnish a small percentage of ions in solution. So like the weak acid above, the weak base, ammonia is a weak electrolyte. Potassium chlorate will completely dissociate, as is the case with really essentially any compound that contains a group 1 metal. It's going to completely dissociate into ions. And so in solution, we are going to have lots of ions present in terms of both the chlorate and potassium ions. This then is a strong electrolyte. And copper nitrate is also a strong electrolyte. Presence of the nitrate ion is an indication of when it's combined with a cation, will completely dissociate into ions in solution, furnishing lots of ions, and that makes a nitrate solution like copper 2 nitrate here um, a strong electrolyte as well.